All right, let's go and continue on. For this part of notes, I'm only going to do example 6, 7, and then I do want to talk about 8. 8, I wouldn't worry too much about it, but let's go ahead and start diving into example 6. So step 1 said that we need to make sure that the inequality has 0 on the right-hand side. That is not the case for example 6, so I am going to go ahead and rewrite it. I'm going to move that 3 on over so that we have is less than 0, right? Now here you are going to have to go and find a common denominator. In this case, my common denominator is an x minus 2. So if this is 3 over 1, I have to multiply both the top and the bottom by an x minus 2. All right, so then we get 2x minus 3 times the quantity of x minus 2 all over the common denominator of an x minus 2. And this guy is going to be less than 0. I can go ahead and distribute that 3, so I get 2x minus 3x plus 6 all over an x minus 2 less than 0. You can keep going, negative x plus 6 all over an x minus 2 is less than 0. Okay, again, equaling it to 0, negative x plus 6 is equal to 0. We get positive 6, so my key numbers are positive 6 and 2. If I create my number line, here's 2, here's 6, and I have 3 test numbers. So my first one is going to be 1. Second one, let's go make it 3. Third one, let's go ahead and make it 7. Okay, so let's go and plug it in. If I plug in 1, so negative 1 plus 6, this is a positive. 1 minus 2, negative. Overall gives me a negative. If I plug in 3, negative 3 plus 6 is a positive. 3 minus 2 is a positive. Overall gives me a positive. If I plug in 7, negative 7 plus 6 is a negative. So overall gives me a negative. And again, it looks like in my original problem, we were looking for negative values. So we're looking for the negative intervals. So here, then my answer choice is going to be a negative infinity to 2, soft bracket, union 6 towards infinity. That's my answer. Okay. All right, I'm going to go and make this guy a little bit smaller so that I have enough room. But let's go ahead and talk about number 7. Number 7 is a little complex. Okay, same exact thing with step 1. I have to go and move that 1 on over. So I'm going to go ahead and rewrite it right above. I get 2x plus 1 all over x minus 1 minus 2 all over x minus 3. And I'm going to subtract that 1 over so that the whole thing is less than or equal to 0. Right off the bat, I know that this is a negative value that we're trying to find. Okay, and again, you're finding a common denominator. In this case, my common denominator is x minus 1, x minus 3. So I have to multiply it out. My first term right here only has an x minus 1, so I have to multiply both the top and the bottom by an x minus 3. Okay, my second term only has an x minus 3, so I have to multiply both the top and the bottom by an x plus 1. And the negative one is special. I have to go ahead and multiply both x minus 1, x minus 3. Cool. So if I write this out, again, we get x minus 3 times 2x plus 1 minus 2 times x plus 1 minus 1 times x minus 1, x minus 3, hard bracket, all over the common denominator of an x minus 1, x minus 3. And I know the whole thing is going to be less than or equal to 0. Okay, my numerator is a big hot mess. Let's go ahead and we'll have to do some foiling, distributing. I'm going to FOIL my first term right here. What is that? 2x squared. That becomes positive 1x minus 6x, negative 5x minus 3. I'm going to distribute that to negative 2x minus 2. Is that right? Nope, I wrote it wrong, sorry. It should be a minus 1. 2 times x minus 1. I was like, that's not right. So this becomes a positive 2. And then I'm going to go ahead and leave this negative 1. I'm going to go ahead and FOIL what's inside. X squared minus 4x plus 3. And then I can go ahead and rewrite my denominator because I can't forget that guy. And then last but not least, I have to distribute that negative 1 on through. So I'm left with 2x squared minus 5x minus 3 minus 2x plus 2 minus x squared plus 4x minus 3 all over my common denominator of x minus 1, x minus 3. And I can't forget to pull that guy down. All right, we have like terms. Let's go ahead and find them. I have a 2x squared minus x squared. That will go ahead and give me an x squared. I have a negative 5x minus 2x. That's negative 7x plus 4x. That gives me a negative 3x. And then I have a negative 3 plus 2. What's that? Negative 1, negative 1 minus 3 minus 4. All over x minus 1, x minus 3. Okay, before we go and do the key numbers, I have to make sure that everything is factored. It looks like I can keep going, right? I'm looking for multiply to negative 4, add to a negative 3. So negative 4 and 1. So this becomes x minus 4, x plus 1, all over x minus 1, x minus 3. And again, this is all less than or equal to 0. All right, now we can go ahead and implement my key numbers. So my key numbers in this case is 4, negative 1, 1, and 3. So here's my number line. Here's negative 1, here's 1, 3, and 4. My test numbers are going to be negative 2, 0, 2, 3.5, and 5. So a lot of things going on. Let's go and plug it in to this guy right over here. Negative 2 minus 4, that is a negative. Negative 2 plus 1 is a negative. And then all over negative. So this guy becomes a positive. Okay, I have 0, 0 minus 4 is a negative, positive, negative, negative. So what is that? A negative over a positive. That gives you an overall of a negative. Test number 2, 2 minus 4 is a negative, 2 plus 1 positive, 2 minus 1 positive, negative. So it's a negative divided by negative. That gives me an overall positive. Test number 3.53, negative, right, positive, positive, positive. So that gives me an overall negative. Test number 5 should give you a positive all the way through. Cool. And again, we're looking for my negative increments. So there's 1, and then there's 2. So then my answer for this one, it looks like, and you got to pay attention to the hard brackets versus soft brackets. It's going to be hard bracket negative 1 to soft bracket 1, union soft bracket 3, comma 4, hard bracket. And the reason why 1 and 3 are soft brackets is because they are in the denominator of my original problem. So that one was a long one. But again, if you guys break it up and figure out, okay, complex fraction, I have to find a common denominator and go through the whole factorization, you guys will be completely fine. All right, example 8. I just want to go ahead and chat about it real quick. So what if there are no key numbers? in examples A and B, these examples do not factor, but we can think about it as their graphs. Okay, so if I'm looking at these quadratics, both of them are positive graphs, meaning that if I graph them, they're going to be something that looks like, let's just say, like that, right? If I'm looking at strictly example A, right, it says that my x values are positive, right? They are greater than 0, so this is positive. So my x values, or I'm sorry, if I'm looking at this like as a parabola, where y is equal to x squared minus 4x plus 5, I'm looking at my positive y values, which is right here, right? So when graphing, I want to think of y is equal to x squared minus 4x plus 5, where the y values are positive in quadrant 1 and 2. And then since the graph is in this positive formation, then I could say that this one is all real numbers. Okay. If the y values are positive and we're looking for positive values, then I could say all real numbers. Whereas problem B, right, my positive graph, but now we're looking for negative values. So I'm looking down below. The graph is not in those negative values, so therefore this one's going to be no solution. Okay, and that's it, right? If you're like, number 8, what? I won't focus too much about it. I want to make sure that we understand the key numbers aspects.